Patient Data Exchange with Azure Health Data Services. So, FHIR Integration Services. It's something a lot of people ask about, and today we're going to walk through it step by step. Now, moving on to what is Azure Health Data Services and how does FHIR fit in. Azure Health Data Services is Microsoft's cloud platform for healthcare data interoperability. It replaced the older Azure API for FHIR in 2022 and bundles three services: the FHIR service, the DICOM service, and the MedTech service. FHIR, Fast Healthcare Interoperability Resources, is the HL7 standard for exchanging healthcare information electronically. It defines RESTful APIs, a common data model across 140+ resource types, and a terminology framework that ties clinical codes like ICD-10, SNOMED-CT, and LINC together. R4 is the version required by the ONC 21st Century Cures Act for certified health IT. If your organization exchanges data with payers or providers under federal interoperability mandates, you need FHIR R4 compliance, not R3, not DSTU2. The ONC's information blocking rules have real teeth. Penalties for health IT developers that block data sharing can reach $1 million per violation. Getting the version wrong isn't a minor version bump issue, it's a compliance gap with regulatory exposure. Let's talk about next up, the core components of a FHIR integration architecture. Building a production-grade FHIR integration services layer on Azure involves more than spinning up a managed FHIR server. Hey race, what a complete architecture actually needs. Every FHIR API should sit behind Azure API management. APIM handles OAuth 2.0 token validation using smart on FHIR scopes, rate limiting, request logging, and API versioning. Without it, you end up with direct FHIR server access scattered across consuming applications, a compliance and operational problem that's hard to untangle later. Smart on FHIR defines OAuth 2.0 scopes like and that map to what a consuming app is permitted to do. Azure Intra ID handles token issuance. APIM validates the tokens before forwarding requests to the FHIR server. The Microsoft Azure Health Data Services documentation covers the full OAuth flow in detail, but the short version is, no valid scope token, no access to PHI. Now, how .NET microservices enable patient data exchange at scale? FHIR integration is inherently a .NET-friendly problem space. The NuGet package and the FHIRly SDK give C# developers typed access to FHIR resources without manual JSON serialization. Combined with .NET 9's performance improvements, this is a genuinely better developer experience than building FHIR clients in most other languages. As a .NET microservices consulting team, we build FHIR integration layers using the microservices pattern specifically because the different concerns, HL7 ingestion, FHIR validation, terminology mapping, bulk export, have completely different scaling characteristics. HL7 ingestion spikes with shift changes. Bulk export jobs run overnight. Separate services let you scale each component to its actual load rather than over-provisioning everything. ASP.NET Development Services built on ASP.NET Core give you middleware pipelines for request validation, dependency injection for FHIR client instances, and minimal API endpoints for lightweight FHIR proxies. Running those services on Azure Container Apps or AKS means you scale individual microservices independently. The HL7 ingestion service scales up during warning ADT message bursts. The bulk export service only needs resources when a nightly job runs. This is what makes .NET application modernization worth the investment. You stop paying for capacity you're not using. Let's talk about now, migrating legacy health systems to FHIR compliant architecture. Most healthcare organizations don't get to start with a greenfield FHIR implementation. They have a 15-year-old .NET framework application talking to SQL Server with proprietary schemas, and they need FHIR APIs without rewriting everything at once. This is where .NET application modernization strategy matters. The honest answer on rewrite versus modernize is that full rewrites fail more often than they succeed. The Strangler Fig pattern is the right approach for most legacy health systems, and it's how we structure legacy app modernization engagements. Legacy.NET Framework modernization uses the Strangler Fig pattern to incrementally replace components without a full rewrite. Here's how it applies to FHIR migrations specifically. Now, next up, security and compliance in FHIR integration services. Healthcare is the highest stakes environment for data security. A breach of a FHIR endpoint doesn't just expose business data, it exposes protected health information with regulatory consequences under HIPAA, high-tech, and a growing body of state-level privacy laws. Every FHIR API request must carry a bearer token. Azure Intra ID issues tokens with smart-on FHIR scopes that define exactly what the caller can read or write. No token, no access. Even internal services, your own microservices calling the FHIR server, should use managed identities, not shared credentials or environment variable secrets. Role-based access control at the FHIR resource level is possible but complex. The FHIR specification supports and resources for fine-grained access control, but implementing them correctly requires careful schema design. Most teams implement coarse-grained RBAC at the APIM layer and reserve fine-grained consent enforcement for the most sensitive resource types. Next up, why choose a .NET development partner for Azure Health Data? FHIR integration on Azure is a specialized discipline. It combines healthcare domain knowledge, Azure platform expertise, and .NET engineering depth. Most generalist teams have one or two of those three, rarely all three. Q Services specializes in .NET modernization with human-in-the-loop governance for enterprise applications. In healthcare specifically, that means every integration milestone, FHIR server provisioned, HL7 converters deployed, security controls validated, goes through a documented review before the project advances. We don't ship to production environments without compliance sign-off from both the technical and business stakeholders. As a .NET development company focused on Microsoft technologies, we use the same Azure Health Data Services platform in our reference architectures. The healthcare-specific patterns we've built, smart-on FHIR authorization flows, HL7v2 to FHIR conversion pipelines, bulk export to Synapse, are production-tested, not proof-of-concept sketches. Next up, real-world FHIR integration patterns that actually work. Theory is useful. Production experience is more useful. Here are 3 patterns that work consistently across healthcare FHIR projects. When aggregating FHIR data from multiple sources, you'll encounter the same patient with different MRNs across systems. FHIR's operation uses probabilistic matching, Jara-Winkler on name fields, SoundX fallback, demographic scoring, to resolve identities. Azure Health Data Services includes a basic match implementation. Most enterprise scenarios need custom scoring weights tuned to your patient population's characteristics. The FHIR 4B subscription model lets consuming applications register interest in specific FHIR resource changes rather than polling for them. A care management platform registers a subscription for and receives notifications whenever a matching patient record changes. This keeps the care management system current without building custom change detection logic on both sides of the integration. Now, next up, conclusion. FHIR integration services on Azure Health Data Services represent a real step forward for patient data exchange, but the technology works only as well as the architecture and governance around it. Getting the FHIR server running takes a day. Building a production-grade integration layer with proper authorization, audit logging, HL7 conversion, and compliance controls takes months of disciplined engineering from an ASP.NET Development Services team that understands both the platform and the regulatory environment. The .NET ecosystem, ASP.NET Core Microservices, blazor Development Services for clinical UIs, .NET 9 Performance, is well suited to this work. Combining Microsoft's managed FHIR infrastructure with a .NET development company that understands healthcare compliance means you're not starting from scratch on either the platform or the patterns. Before you write the first line of FHIR integration code, understanding why healthcare IT projects fail is worth your time. Our post on why healthcare IT projects fail at compliance, not code, covers the non-technical reasons these projects stall, and most of them are preventable with the right governance structure from the start.